I'd like to begin by reiterating something we all already know, that humankind's most pressing challenge is the education of its next generation. And judging from the current state of the world, we're not doing very well. So I'd like to tell you my thoughts on the subject, show you what I've done so far, and propose a potential advance that I believe addresses this problem across all fields at college, high school, and possibly even middle school levels. Recent education reform has been complicated by misguided theories of poor educational performance. For example, large class size was blamed until the Gates Foundation took this claim seriously, spending $1 billion to actually reduce class size, but failing to improve student learning. Inattentive students have also been blamed, leading to clicker-based testing of them every few minutes. Unfortunately, such frequent testing can't help but increase anxiety in student populations already pathologically anxiety-ridden and plagued with rising levels of mental illness in general. This study shows increased anxiety levels in 2017, and COVID has further exacerbated the problem. And here's another study of student anxiety. Note that all students in it reported experiencing anxiety attacks. Terrible experiences no student should endure at all. So perhaps we should consider potential solutions that actually decrease student anxiety. But first, let's return to the issue of what's wrong in the first place. Indeed, it's obvious that inadequate teacher knowledge should take some of the blame for poor student performance, especially in underprivileged areas of the world. But even in the best of schools, we must all admit that it's a problem. For example, the first time a professor teaches a course, let's face it, he's learning along with the students, which isn't good. In addition, student learning at all levels is further hampered by another serious lecturer inadequacy: poor oratorical skills. Lecturing is actually quite challenging, and many teachers and professors simply lack the necessary sophisticated skills to effectively communicate even the knowledge they do possess. Indeed, one reason I recorded this talk was so that I could edit out all my ums and ahs and poor word choices, not to mention stutters. These two issues explain much of the failure of class size reduction, which necessarily meant hiring additional teachers. But there are only so many good teachers, and they'd likely already been hired. Worse, lecture preparation is enormously time-consuming, generally requiring several hours per hour of lecture time, especially initially. Worse still, lecture notes are just not helpful to other lecturers, and so aren't worth sharing. As a result, the task of preparing lectures is currently performed from scratch and independently, and hence massively redundantly, by every teacher on earth. In other words, the world's current educational lecture paradigm is analogous to that of books before Gutenberg's invention of the printing press. As a result, lecture preparation by the world's approximately 50 million non-primary school teachers currently absorbs tens of billions of human hours annually, corresponding to a cost of roughly $1 trillion a year. $1 trillion here, $1 trillion there. Eventually it adds up. Okay, it's already added up, and to a lot. And it continues to add up every year. And what are we getting for this exhausting effort and never-ending enormous cash outlay? Well, even at its best, the class lecture continues to comprise a stark talking head chalking a bleak featureless blackboard, a teaching style developed by the ancient Sumerians using a stylus to inscribe cuneiform on a clay tablet. While it was a good idea then, the class lecture hasn't really improved in the 5,000 years since then. Sadly, the class lecture has even nearly completely sat out the spectacular ongoing digital revolution. Big moments in recent Blackboard history occurred in the 1970s when they turned green, and then more recently when they turned white. But we're running out of colors. Indeed, the talking head is well known to be the very symbol of monotony, so pitifully dull that a popular 1980s counterculture rock band named itself after it ironically. Such lectures just beg students' minds to wander off to much more exciting modern distractions. Interestingly, the current talking head class lecture paradigm is actually in some sense the complement of that of pre-Gutenberg books. Even at that time, books were wonderful inventions. They simply lacked mass production capability. Today, with digital memory and the internet, mass production and even mass dissemination of recorded lectures are trivial. But the Chalk and Talk class lecture is so pathetically boring that it's simply proved itself not worth mass-producing, or even recording, or for many students, remembering. A colleague of mine actually did record his Chalk and Talk lectures during the pandemic. So I asked if he himself had watched them afterward, and he replied, "Hell no, do you think I'm crazy?" On the other hand, teenagers are remarkably adept at remembering minute details of popular movies they've seen years earlier. But they often can't recall the main ideas of their math class the previous day. They can accurately quote Yoda's ungrammatical lessons, but not yesterday's unengaging ones. By the way, note that this simple fact debunks the common, but except at the lowest grade levels, mistaken presumption that in order for students to learn, there must be close human interaction, or in fact any human interaction at all. Clearly, the quality of the message is much more important than its messenger. The inevitable conclusion is that the main problem in education is the lecture concept itself. So it's time to reinvent it. Admittedly, some lecturers use PowerPoint and classroom projectors, but they rarely take advantage of its many powerful features, and its use is nearly always merely a substitute for lecture notes, a crutch, leading to its terrible reputation among students and teachers alike. No wonder the legislature of the country of Egypt actually proposed a law banning PowerPoint, and a Swiss political party is devoted entirely to the same goal. And Katrin Park, a former UN staffer, agrees. And to prove her case, she created a very compelling PowerPoint presentation. Okay, in fairness, her presentation intentionally consisted mainly of examples of poorly designed slides, either far too simple, like this, or far too complex, like this. In fact, she was actually mainly opposed to bad PowerPoint presentations. We all certainly agree with her. So what kind of next-generation lectures could arise? Well, ideally, we could imagine all classes showing PBS Nova-style documentaries. They're colorful, visually exciting, interesting, well-scripted, well-narrated, and technically essentially perfect. They're also recorded, and so can be paused, rewound, and repeated. I think we'd all agree that Nova is near the top of this crude plot I've made of the excitement level of a lecture versus the skill, cost, and/or effort required for its creation. But it's also at the extreme right. Only an hour long, each episode costs $500,000 to create. And worse, numerous highly skilled individuals and sophisticated equipment are also needed. Now consider the other extreme. Current educational products, standard Chalk and Talk lectures. I think we can all agree that, although they still require many hours of effort, they live at the bottom of my chart. And most people agree that most PowerPoint lectures have also justly earned a similar position. And textbooks, despite requiring a huge amount of effort to write, just aren't exciting to most modern learners, so they also live at the bottom. Indeed, these three latter approaches are all below my personal cutoff on the excitement scale, and probably yours too. But PowerPoint has the potential to be exciting. It allows color, animations, audio, video, and applets, potentially yielding multimedia lectures that could be quite exciting. Indeed, they have the potential to be near the top of the chart without the cost, skills, and effort level of a Nova episode. Today's learners see these exciting features in other aspects of their lives, so why hasn't PowerPoint accomplished this? Well, obviously, because it still requires a great deal of effort, and no one has that kind of time. Except for me. It turns out that I've actually had that kind of time. The School of Physics at Georgia Tech has kindly allowed me to teach optics over 20 times, and I chose to obsessively improve my PowerPoint lectures every year. And I'm here to show you what this much effort by someone with only a laptop can accomplish by simply spending a great deal of time. I've created over 24 full-length lectures with thousands of animations and photographs, and I've also taken heavy advantage of image and video content uploaded to the internet by others. I've even carefully written narration scripts and painstakingly recorded narration for them during the pandemic. They're now essentially complete. I also share them on my website, frog.gutech.edu, resulting in their use by lecturers and students worldwide, even before I narrated them. And lecturers and students also routinely provide feedback to improve them. Assistant professors are the most appreciative. These lectures save them hundreds of hours of lecture preparation time during a period in their lives when time is in short supply. I've also created an analogous narrated modern physics course. It's particularly enjoyable, I believe, because I teach it historically, and its cast of colorful characters adds greatly to the fun. These two icons link to the two courses' lecture files, which can all be downloaded. So could such multimedia PowerPoint lectures be created for and shared in other fields? I use only a laptop, freeware, and PowerPoint, which everyone already owns, and everyone knows how to use it. Before we continue, let me show you a few slides from these lectures. Here's a photograph I took to illustrate a small depth of field. Technical drawings are easy in PowerPoint, and here's my drawing of the sun illuminating the Earth and the resulting atmospheric light scattering. Here are two more photographs to illustrate atmospheric polarization effects due to light scattering. And another I took to inspire the study of nonlinear optics. But motion is much more exciting. So here are some electronic and molecular vibrations. And electromagnetic waves propagate. An animation of one is worth 1,000-word hand-waving explanation. And stimulated emission and its chain reaction in a laser are also better illustrated using animation. And here's a simple illustration of Boltzmann population factors for a high and a low temperature. Derivations are much easier to present when diagrams, labels, variables, equations, and cancellations pop up precisely when you need them. Here's my derivation of Snell's law, significantly sped up here because you won't be tested on it. And my derivation of the ray matrix for a curved mirror, also significantly sped up. Describing absorption, spontaneous emission, and stimulated emission is much easier with an animated graphic. And the Doppler effect becomes obvious with a little animation. Explaining how a laser can use a saturable absorber to generate ultrashort laser pulses benefits from animations like this. Now, as I mentioned, I haven't created all the content by myself. I've also used images and GIFs from the internet, and most such uses satisfy all four of the conditions of the fair use doctrine. The internet is full of beautiful images for educational purposes. Here are amazing illustrations of strain induced by refringence, and pulsed light beams crossing at an angle yielding irradiance fringes. And describing Isaac Newton's views of whether light was a particle or a wave is much more illustrative with these GIFs. And here are images of interference from two point sources emitting spherical waves. It's easy to see that the fringes are an angle and are farther apart when the sources are closer to each other. And circular polarization is a difficult concept to explain or draw on a blackboard. A video is really necessary. And don't even try to explain an optical vortex in only words. Explaining what incoherent white light really looks like is also tough, but this speckle pattern happens to be what spatially incoherent monochromatic light looks like on a microscale, and this colorful movie shows what light bulb light looks like with ultrafast temporal resolution. And to explain special relativistic velocity addition, animations really help, especially as the Enterprise is destroyed. But fortunately, that's only when the velocity addition is Galilean. Relativistically, it survives to seek out new worlds and go where no one has gone before. And explaining Lorentz contraction is vastly simplified with cute graphics like this. Same for this beautiful movie of a quasar, without which a discussion of cosmology just wouldn't be satisfying. Such recorded, narrated multimedia lectures have many advantages. First, as mentioned, they're visually very appealing. If created by highly skilled instructors and narrators, they'd transform lectures from dismal tedium to dynamic television. For example, at the right, you're enjoying a GIF of the electric field vector versus time of unpolarized light, created for me by Thomas Augustin, a grad student from the International School of Photonics in India, who's made a number of very nice GIFs for my lectures. Second, also as mentioned, their scripts can be highly optimized, with concise language, interesting background facts, anecdotes, and historical information. Unlike the often inaccurate, on-the-fly word choices and instructor memory-limited information of even a well-prepared traditional extemporaneous lecture. Third, like movies, their narration doesn't disappear into the woodwork once uttered. They can be watched anytime and even many times, a feature that clearly plays a key role in popular movies' memorability. Fourth, their watch-at-leisure nature would eliminate an entire set of college student deadlines, and also the often encountered difficult choice between attending a class of one course and finishing the homework of another. Of course, at lower levels, they could be watched in class and frequently paused and discussed, and the students could keep them as souvenirs to watch again when studying. Either way, reducing student anxiety. Fifth, the PowerPoint versions of such lectures can be searched for keywords while doing homework. This was discovered by my students. And sixth, they're easily shared with the world, as I'm already doing, as I mentioned. So students anywhere in the world can learn from the same visually stimulating, audio-optimized lectures that I've spent thousands of hours creating. As a result, such recorded lectures would solve the redundant effort problem, saving the many billions of hours of teacher time currently wasted annually. Want to hear the first few minutes of my modern physics course? The story of modern physics may well be one of the greatest stories ever told. It has as many twists and turns as a theatrical murder mystery. And some of the twists are so mind-bending that you won't believe them when you first encounter them. And whether we're talking about the physics or the physicists, it has a diverse cast of fascinating and colorful characters. Like theater, it begins innocently enough, with everything apparently under control and everyone happy. Then numerous cracks in this blissful state of affairs begin to emerge. Complex subplots abound. Players encounter crisis after crisis, with things often looking quite bleak. But in the end, a wonderful resolution emerges, comprising a completely different picture, with numerous victims falling by the wayside and new heroes emerging to save the day. It even ends with hints of a sequel. Of course, the sequel hasn't been written yet, and perhaps some of you will play a role in it when it is. And most importantly, unlike theater, it's all true. This course won't just be about modern physics. It'll also tell the story of modern physics, that is, its history. It'll begin in the mid to late 19th century. It was a time when physicists blissfully thought they had everything figured out. Indeed, American physicist Albert Michelson wrote in 1894 that the more important fundamental laws and facts of physical science have all been discovered, and these are now so firmly established that the possibility of their ever being supplanted in consequence of new discoveries is exceedingly remote. Our future discoveries must be looked for in the sixth place of decimals. Ironically, it was Michelson himself who a few years earlier had discovered one of the first great cracks in the foundations of the physics of the time that led to the chaos that ensued. And British physicist Lord Kelvin wrote in 1900 that there is nothing new to be discovered in physics now. All that remains is more and more precise measurement. Physicists had the apparently rock-solid work of Isaac Newton, which described the motion of all bodies. In addition, Lord Kelvin had performed exacting experiments to determine the behavior of gases. And physicists of that time even had an excellent grasp of waves, although waves were more often considered a fringe subject than a fundamental quantity. The fundamental entities of the universe were particles, and waves, such as sound, were simply collective motions of them. Conservation of energy, linear momentum, angular momentum, and charge had been discovered and provided spectacular insight into the laws of motion and thermodynamics. And thermodynamics had firmly established the atomic theory of matter. Only a few minor issues remained to be ironed out, such as the precise nature of atoms and light, and some odd electromagnetic phenomena, and a correct formula for the spectrum of hot objects, which had proven frustratingly elusive. In hindsight, we can rightfully state, oh, how very wrong they were. Although they didn't realize it, they were about to experience the greatest scientific adventure of all time. How about the first few minutes of my optics course? Light is amazing, and humankind has been justifiably fascinated by it from the time our species became sentient. Let there be light was the Judeo-Christian deity's first and most important task. Hindus worship light as divine and omniscient, and their festival of Diwali symbolizes the victory of light over darkness, knowledge over ignorance, good over evil, and right over wrong. Festivals of light are also celebrated by many other cultures, and here's a photograph of a beautiful one at the Cincinnati Zoo and Botanical Garden. Nearly everywhere in the world, light is the symbol of joy and life-giving power. Indeed, a person is a great joy if he or she is the light of one's life. A charming person is said to light up a room. A wise person is a guiding light. And when we're finally making progress, we can see the light at the end of the tunnel. A good idea is symbolized by a light bulb over one's head. And we often shed some light on a subject to become more enlightened and eventually see the light. From the moment we awaken in the morning until the moment we fall asleep at night, light is our main tool for understanding and interacting with the world around us. And with the use of optical devices like microscopes and telescopes, light has given us the entire fields of biology and astronomy. Light was responsible for the great revolutions in physics in the early 20th century, quantum mechanics and special relativity, and it plays a key role in general relativity as well. Even today, in ongoing tests of the fundamental nature of physics and reality in general, light is the key element. Light is also practical. It's at the heart of the great technological revolutions occurring now in telecommunications, geopositioning, weather forecasting, and medical and military imaging. In this course, we'll talk about all aspects of light. We'll begin by asking simply, what is it? Is it a particle or a wave? Or somehow both? This debate has continued for centuries, and although our understanding of it has increased drastically, we're still refining our precise answer to this question. But we can definitively answer many important questions, and their answers provide answers to many other long-standing questions. They include, how does light interact with matter? How does it interact or interfere with itself? And why do things look the way they do? What gives an object its color? How do prisms disperse light into its many colors? Why is the sky blue and clouds white? Why is water in some cases clear and in others blue? Why are some surfaces shiny and others not? Why do windows look like mirrors at night? We'll answer all of these questions in this course. We'll also resolve some 19th century dilemmas and talk about lasers and the many ways they're different from light bulbs. And we'll talk about rainbows, sunsets, polarized sunglasses, cameras, concert holograms, mirages, and butterfly iridescence. In short, we'll not only develop a detailed understanding of light, but we'll also use this understanding to explain a wide range of optical phenomena and answer many questions you may already have about the world and its appearance, and many you perhaps haven't thought to ask. In this first lecture, I'll provide you with a brief history of optics, and I'll outline in more detail precisely what we'll cover in this course. But how well have they worked in practice? Well, it's too early to be definitive, but remarkably, they completely solved one pesky universal problem immediately: the ubiquitous exponential decay of college class attendance over the semester. Indeed, in my optics course last fall, because they could watch them anytime they liked, all the students reported watching nearly 100% of the lectures, likely a world's record for voluntary class attendance in a semester. One student actually binge-watched all the lectures and finished the entire 15-week course in just 6 weeks, and she achieved a grade of 98%. Also, subjectively, the students reported greatly enjoying them. Finally, grades have been spectacular, mostly A's, for the first time in a course of mine. By the way, this was during the peak of the pandemic, when student grades generally fell significantly elsewhere. So I believe that this approach is working very well so far, despite the fact that my lectures remain works in progress. But wait, this isn't the first time that video lectures have been proposed. Over a century ago, Henry Ford suggested that movies of lectures would revolutionize education. So why hasn't this happened already? Well, first, the only thing more boring than a talking head is a video of one. And almost no one has the time, skill, or funds to create audio-visually exciting educational lectures for an entire course and then give them away. The insightful tech commentator Derek Mueller, who goes by the internet name of Veritasium, nicely summarized this issue, reviewing the results of decades of educational research, which has depressingly indicated that the most successful educational tool that humankind has come up with so far is the truly inspired teacher. Alas, as I mentioned, such inspired teachers are in short supply. But times have changed, and over the past couple of decades, as I mentioned, millions of inspired individuals have uploaded massive numbers of beautiful and informative images and video to the internet, which are freely available or usable via the fair use doctrine for nonprofit educational use. Indeed, Wikipedia has a spectacular array of excellent photographs, diagrams, and animations on literally every subject. In addition, government websites like that of NASA have some of the most beautiful and informative images ever published. Furthermore, many commercial sites simply give away helpful and educational images and video. As a result, the visual component of multimedia lectures has now suddenly become orders of magnitude easier. In addition, inexpensive audio recording equipment in the form of the latest generation of laptops released during the pandemic, in part for pandemic-related applications, incorporates significantly improved built-in microphones and have recently significantly simplified recording professional quality narration. The latest MacBook Pro's microphone is generally considered at least as good as professional external microphones. And even better, text-to-speech computer algorithms now generate quite human-like narration and will soon make manual recording of narration unnecessary. Companies like Descript, WellSaid, and Murph AI have made great strides. I've actually had my voice cloned, so see if you can figure out which parts of this lecture were in fact spoken by my voice avatar and not me. Want to hear Murph AI's voice, Eliza?
From the dawn of civilization, humans have pondered the nature of the universe, its origin, its size, its shape, its composition, and its future. So the study of the universe, the field of cosmology, may very well be simultaneously the oldest and most universally fascinating field of science, with nearly every civilization weighing in on the subject, albeit not usually particularly scientifically. And as we've done with all other fields of physics, we'll begin our study of cosmology in the late 19th century. And at that time, physicists also had a surprisingly primitive view of the universe. Despite having used Newton's laws to successfully model the motions of the planets, moons, and comets in our solar system for over 200 years, they hadn't considered the possibility of doing so for other, more distant celestial bodies, which they also continued to simply and naively call the fixed stars. This was most likely because they knew almost nothing about these objects. While stars were easily seen, and some appeared to be slightly different in color, that was about all anyone knew about them. They were unresolvable points of light, and even with today's most powerful telescopes, remain so at visible wavelengths. On the other hand, 19th century physicists were aware of an interesting calculation that piqued their, as well as others' interests in the subject. And it's called Olbers' paradox. It was a simple calculation of the theoretical brightness of the night sky due to all the fixed stars in the universe. And it yielded a startling result: infinity. So the night sky should have been infinitely bright, which of course it wasn't, and by a long shot. As a result, if anyone at that time had felt that cosmology lay within the realm of physics, Olbers' paradox could easily have been included by Lord Kelvin in his 1900 speech as a third dark cloud on its horizon.
Okay, it's not perfect, but it's not bad, and it's getting better. Since I created this, variable controls over emphasis and other aspects of the narration have been introduced. More importantly, such programs will also allow continual modification and improvement of the lectures by anyone, anytime. In any case, the potential of multimedia video lectures to change the educational world cannot be legitimately dismissed based on outdated studies involving obsolete technology and uncreative approaches, like a talking head armed with only a piece of chalk and a blackboard. Indeed, ironically, Veritasium told his story in a very exciting multimedia video lecture. And also ironically, he did so on a multi-billion-dollar website that's thriving spectacularly by offering only multimedia video lectures, a website routinely watched by almost 2 billion users who either pay or endure ads to do so. While admittedly many YouTube videos aren't very educational, on the other hand many are. And consequently, we absolutely should not make the naive mistake of dismissing the educational power of multimedia video lectures. So in the end, Henry Ford was right, but just a century ahead of his time. Indeed, video is an increasingly significant part of our lives. We currently watch several hours of it per day on average, and this number is increasing rapidly. And the percentage of kids watching online videos every day is also increasing. In 2019, almost every young person in the US was already self-educating via video. And by now, we could probably remove the word almost from that sentence. Of course, we still can't expect already overworked teachers and professors to have all the skills, and especially the time, to create such multimedia video lectures. But we don't need to. We only need one. Or, better, one team of teachers or professors per course. Indeed, a team of several knowledgeable teachers or professors, each with one or two of the required skills, could create an entire analogous course of such lectures from scratch in about a year. And my hope is that a philanthropic organization could pay them to do it, providing grants of, say, $200,000 per team per course. Creating 50 high school and 200 college courses, each at 2 different levels, would require a one-time investment of $100 million, a small fraction of the $1 billion spent to temporarily reduce class size, and a minuscule fraction of the current worldwide redundant lecture preparation effort. And the resulting recorded lectures would be a permanent contribution to humanity. And there's another huge pool of highly motivated but untapped labor. Students, who are always in search of extra credit and who enjoy doing this sort of thing, which is an ideal extra credit task. Today's students have all the skills to do so. Indeed, for extra credit, my students have translated my optics lectures into both Spanish and French. Now, these lectures wouldn't replace, and instead would nicely complement, textbooks, which are less exciting and aren't free, but contain much more detailed information than could be provided by such lectures. A mutually beneficial relationship would exist with textbook publishers, who could, say, provide images for these lectures in return for hyperlinks to the publisher's website, so motivated students could easily buy the textbook. And I cannot emphasize enough that such lectures should never replace teachers and professors, and would be used to enhance teaching and eliminate only the need to prepare lectures. They'd only be used in place of teachers where no qualified teachers exist. But liberated from the tedious chore of lecture preparation and the need for complete mastery of a subject and the sophisticated lecturing skills to communicate it, teachers everywhere would spend their newly available time working more closely with their students and also learning more about the subject. So we should, of course, continue to spend the $1 trillion or so a year on teachers, but their lecture preparation time can be redirected to these more important and consequential activities. I believe that the consequences of such a long overdue paradigm shift in education would be dramatic and entirely highly positive. Obviously, as I mentioned, the resulting video courses would eliminate the massively redundant worldwide simultaneous preparation of essentially identical lectures. In other words, they'd do for lectures what Gutenberg did for books. With the simplicity and efficiency of digital copying and the internet, massive worldwide dissemination of high-quality, philanthropically funded lectures would be effortless and not merely low cost, but free. Of course, as I mentioned, the world has had this dissemination capability for over 2 decades, but now there will be lectures worth mass disseminating. Furthermore, in countries hostile to the education of girls could quietly and privately use such lectures to self-educate, achieving progress towards solving another of the world's appalling problems. Also, such lectures would be ideal for homeschoolers, especially critical during pandemics. Finally, they could become a source of truth in an increasingly propagandized and misinformed world. This is important even in first world countries where misinformation is also rampant. In short, I believe that this transformation is long overdue, and with their newfound more complete knowledge, the resulting better educated and wiser young graduates could provide additional, unanticipated benefits for the entire world for the foreseeable future. Quality education should be a basic human right. Unfortunately, it's seen as too expensive by many in power. But I don't think that should stop us, and I'd like to propose a major, philanthropically funded, worldwide effort to develop multimedia, entire courses of lectures at all levels using PowerPoint or similar program that would be free, easily edited, and continually improved by anyone and everyone. The lectures would be shared online and would save countless hours of lecture preparation time for teachers while simultaneously increasing student learning significantly. Because internet access and display devices will soon be available everywhere, such an effort would benefit everyone in the long run, but especially the world's poor and underprivileged, who need such a development the most. Thanks for listening.